Ate tukyali mu Somera mu Ddiirolyo ng'olunaku olwokutaano enteekateeka gye twabateerawo nti olunaku luno olwokutaano n'olwomukaaga twabateerawo enteekateeka endala ey'enjawulo nti oluvannyuma lw'okuba nti abayizi babeera basomeseddwa ebintu bingi babeera babanguddwa mu bintu bingi era ne babikwata naye weetaagisaawo okubongeramuko ate obukodyo butya bwe basobola okuba nga bayita ebigezo nga bituuse nga bakozesa bino bye babeera bayise aba bye babeera bayize wiiki ennamba ensonga lwaki tuleeta abakugu mu masomo ag'enjawulo ne tubaleeta ne bongera okukuba torch n'okuwa abayizi obukodyo obw'enjawulo. Enteekateeka eno eteekebwamu ensimbi bannaffe abamuteesa wano Royal University ey'obwakabaka bwa Buganda bakujjukiza nti bakyagenda maaso n'okuwandiika ate abayizi mu kiseera kino mu intake ey'omwezi ogw'omunaana mu masomo okuli education, information technology, engineering, mass communication, social sciences, business administration, commerce, tourism, hotel management, kwoteeka n'amasomo amalala mangi ddala. Bayina ku ddala erya certificate erya diploma wamu ne degree. Genda weewandiise wali ku kitebe ekikulu ekirumba Masaka oba ku ttabi erya muteesa wano Royal University wano Kakeeka Mengo ojja kuba nga ate omanya ebisingawo ebikwata ku University y'obwakabaka bwa Buganda. Sobola obbakubira ku ssimu 0754 8 368 0754 8 368 ojja kuba omanya ebisingawo ebikwata ku muteesa wano Royal University ey'obwakabaka bwa Buganda. Osobola n'ogenda ku kibanja kyabwe www.mru.ug n'omanya ebisingawo ate ebibakwatako. Ne bannaffe aba Buganda Examinations Council BECO nabo tutambula nabo wano Somera mu Ddiirolyo okubangula gwe omuyizi butya bw'oyinza okuyita ebigezo nga kano kakiiko akavunaanyizibwa oba ekitongole ky'obwakabaka bwa Buganda ekivunaanyizibwa ku bigezo n'okwongera okulondoola ate ebyenjigiriza bitambula bitya mu bwakabaka bwa Buganda n'eggwanga lyonna okutwaliza mu Buganda Examinations Council baseetinga ebigezo babigolola kwoteeka n'okulondoola ensomesa y'abayizi ate mu masomero agatali gamu be tutambula nabo wano mu Somera mu Ddiirolyo mu kanyomero kano. Mu ngeri y'emu njagala okuba nga nkujjukiza nti ku ssaawa eno omukolo ogugenda mu maaso mu ggwanga gwe gw'okuziika Major General Kasirye Ggwanga wali mu bitundu eby'Emityana nga bw'olengerawo omukolo gugenda mu maaso era nga abantu batonotono abalondeddwamu okwetaba ku mukolo guno. Agenda kuziikibwa mu bitiibwa eby'amagye era nga enteekateeka yonna UPDF egitaddewo n'emizinga gye bagenda omukubira gyonna tugirabyeko weebiri. Agenda kuziikibwa mu bitiibwa ebijjuvu ebya General ow'eggye ly'eggwanga. N'olwekyo tugoberere ku mikutu gyaffe egya social media okusobola okuba nga ate ogoberera bulungi omukolo ogwo ku Twitter kwe tuli nnyo butereevu, ku Facebook kwe tuli butereevu ate n'emikutu emirala egya social media. N'olwekyo oba otugoberera wakati nga ate bwe tugenda maaso n'okuweereza ebirala wano. Kakati olwayo tugenda ku ssaawa ne tugenda mu physics paper 1 O level nga tuli n'omusomesa Kasirye Richard okuva wali ku Ndejje Senior Secondary School yagenda okutuyisamu mu bukodyo obwo butya bw'osobola okuba ng'oyita physics paper 1 O level. Byonna by'osobodde okusoma wiiki eno osobola kubissa otya mu nkola ng'ekigezo kituuse. Kale katugende mu kiraasi mu kiseera kino.
Thank you very much, presenter, for the remarks. A very good morning to you all, our esteemed viewers, especially the senior 4 candidates. My name is Richard Kasirye. I'm a senior teacher of physics at all levels. It's a pleasure to be here. I want to thank the management of BBS Television for this wonderful opportunity. I'm grateful to my colleagues who have been here before. Trying to digest to go through the different areas. Dear colleagues, I do appreciate. In a special way, I want to thank the Buganda Committee for the Examination, that is BECO, Buganda Examination Council, for entrusting me with this noble task, where it is my chief duty to teach the student of this country. So that is basically the preamble. I was given a very simple task to handle question approach pertaining to paper 1, physics. The paper code, it is 535/1. Dear candidates, you will remember that we have 2 theory papers at senior 4. That is so we have 535/1, that is paper 1. There is 535/2, that is paper 2. And of course the practical papers, paper 3, paper 4, in that order. So I'm here purposely to hint on paper 1, the do's and the don'ts, and what we can do to excel in that paper. So that is the major target for today. Our talk will center around the 3 areas. 1, I will talk about the basic tips. Then part 2, I will look at part 2, look at the examination targets, and finally we'll be looking at the key words, the technical terms which we use as far as this paper is concerned. Briefly, to take you through paper 1, we are all aware that paper 1 has got 2 sections. It has got 2 sections. There is section A, and this consists of 40 objective type questions. Each is marked out of 1, so the total will be 40 marks. When you go to section B, it has got 10 structured questions, and each is marked out of 4. Again, the total will go to 40 marks. So you observe that at the end of it all, the paper is marked out of 80. So it is good at least to maximize. If you can get like 70 and above, that would be very wonderful. So you want to see basically how can you excel in that paper. So let's begin by looking at the basic tips. Now, under the basic tips, these are the general tips, but of course with paper 1, I'll be emphasizing some few areas. We have some 10 items here, but I will try to summarize them. 1, I will just say that you don't have to panic. Members, we are aware that physics is a little bit challenging, and in most cases, very many learners tend to panic, and at the end of it all, they fail to score highly. So when I say don't panic, it may sound obvious. Well, it is obvious, but it is hard, because at times it is typical of human nature that someone has just panic. But if you may be given any problem, what you have to do is to confront it. Just remember, these are problems, these are questions. You may fail number 1 and maybe pass some other questions. So there's no penalty, maybe if you fail the first question and maybe pass the other question. So just relax, you concentrate, and of course at the end of it all, you'll come up with the best scores. So you should get rid of what? Get rid of panic. You don't have to fear. Don't forget that these are just questions. So when you do it, you definitely come up with the required solutions. As I've already put it in section A, which I said we have 40 objectives. In this case, a learner is expected to give the most correct alternative. You are given 4, A, B, C, D, but of course you have to pick out the most correct alternative. The second item here, excuse me. So item number 2, you have to try to understand the situation. What do I mean? If you are given any question, it is your task to know where is it coming from. Is it from mechanics? Is it from electricity? So the moment you understand that, you'll be on a very safe side. So if it is maybe from light, again, you have to remember which part exactly. And once you do that, in that case, you'll be able to handle such a question. So try to understand the situation. Where is the number coming from? Is it light? And so on. Item number 3, under the basic tips, these are just basic tips. Read the question carefully. This is very important. The moment we do the question very carefully, it implies you will understand what has been given. And the moment you grasp everything in the question, of course, there is no way I will fail such a number. So just try to look at the question as it appears or as it has been said, digest it, and try to interpret what has been given in the question. So some answers are very funny. When you're given a paper, you just start off, but it is important that you go through all the questions and maybe you understand how to go about it. Number 4, organize the information. Yes, when I talk of organizing the information, what do I mean? Here I mean you have to look at what has been given, then you summarize the key areas, and the moment you summarize, you will be in a position to know what has been given, what is available, and what is required. So it is very important that you try your best to organize the content, to organize the material, and look at what has been given. So when you do that, you'll be on a very safe side. Number 5, sketch the scene. Now, when I talk of sketching the scene, what do I mean? Here I mean, you see with physics, there are some numbers which require sketch drawings. For example, when you go to force, and even some other areas. If you are given any question, try to examine it and see. Maybe a sketch will be very important. If you are looking at, for example, linear motion, they are talking about velocity time graph. It will be very important to sketch, and at times, such a drawing will help you to come up with the required solutions. So try your best to study what is in the question. After understanding what has been given, you have already maybe gathered your content, the material which has been given, then you do the sketch. Such a sketch will help you to come up with whatever is required. Number 6, verify the units. Verify the units. Yeah, dear candidates, you are aware that in physics we talk of SI units. So sometimes we may be given some questions when maybe some quantities are not in SI units. For example, distance. Such values may be given in centimeters, and maybe some other quantities. Mass may be given in grams. So if you have to make maybe any substitution somewhere, everything must be in what? Must be in SI units. So the moment you don't check your units, what has been given, at the end of it all, you end up getting what? Wrong results. Even if you have the right formula, it will cost you somewhere. So please, try as much as possible to verify what? To verify the units. Number 7, under the basic tips. These are the general tips, but of course you need them in paper 1. So number 7, you have to consider consider your formulae or formulas, whatever, and can work. You can say formulae or formulas, there's no problem. So in physics, we have got a number of expressions which you can use. When you go to motion, you can talk of the equations of motion. There are very many. When you go to electricity, you can talk of Ohm's law. So there are quite a number of expressions which can be used, which you are already verified. So if you look at what has been given, it will help you to understand maybe which formula to apply, which formula to employ. So try to look at the content given after doing maybe after summarizing, and then after that you'll be able to recognize which formula to employ. Number 8. Number 8, solve. Now, after looking at maybe the expression to use, the units have been verified, you have a sketch drawing. Now you can go on to solve. Here you can make a choice of which formula can I employ, which formula can I use. When you do that, then you just feed in your quantities, provided all in SI units, and then you do what? And then you solve. When you solve, of course, you come up with some result. And when you get that result, don't just stop there. You have to move one extra step, and that is you have to verify your results. Verify your results. Now, verifying your results means in physics, most of the quantities are known. For example, if you are looking at efficiency of a machine, we know that it must be less than 100%. Now, it would be very funny for somebody to get a value of efficiency of a machine when it may be 1,000. Then that means somewhere you misfired on the way. That's what we call a verification. When you proceed, I will give another example. The value of G, the acceleration due to gravity, we are all aware that the value of G is around 9.81 meters per second squared. This implies that if you're looking for the value of G and maybe somewhere you get 200 something in the same unit, if everything is in SI units, it implies somewhere you did misfire. If you're looking at the speed of a car, or the velocity of a car, whatever the case, and maybe you get your value when it's bigger than the speed of light. The speed of light is 3.0 exponent 8 meters per second. So if you're looking at the speed of a car and then you get something almost in that range, what does it imply? It implies that somewhere you misfired on the way, you didn't use the correct formula, or you made some wrong substitution. So you have to go back and check if all the quantities are given in SI what? In SI units. So that's verification of what? Verification of the results. So friends, I do believe that once you do that, you will be on a very safe side. And maybe lastly, under item 1, it is practice. It is practice. I'll repeat, practice, practice, practice. There is no way I will perfect in physics unless you do what? Unless you practice. So when you practice, everything becomes very simple. But if you just sit and wait for exams, you'll be in trouble. So friends, try to practice, and when you do that, you'll be on a very safe side. So as I did mention in the start, our talk is basically on question approach. Item 1, it is the basic tips or skills, and item 2 is examination targets. So we go to the second item, and that is B, examination targets. Yeah, as I did mention in the start, physics as a subject is a little bit challenging, and it may be complicated to some students or to a good number of students. Therefore, we have to look at what is in paper 1. What do exams look at? Now, in physics paper 1, exams normally center around 3 things. 1, we test vocabulary. We test vocabulary. So we look at applications. So we range from vocabulary, because we have a number of a number of terminologies that may be examined. We look at applications to real life situation. If I talk of machines, where do we make use of those machines? We look at problems, problem solving. Just know that any issue in physics has got applications, and we look at it as as a problem. So we'll go into details and look at that arrangement. So in details, we can say that the targets actually which you look at in paper 1, if it's an exam, we basically look at terminologies of concepts. So we look at terminologies of concepts. Yeah, when I talk of concepts, there are very many in physics. Give an example, there is momentum, acceleration, velocity, that's if you go to motion. If you go to waves, there are very many crests and others. But of course, your concern should be one, to know the different terminologies. As I've already put it, this paper is somehow broad. So this calls for mastery of content. So there's no way how we will define maybe the various terms, the various concepts, unless you have been reading. So reading is very important, and once you do that, all the concepts will be at your fingertips. A number of them, of course, will be surfacing. What I'm sure of is, if you look at paper 1, the way how it is set, you may end up getting some 10 definitions. At times 8 around there. So when they say define, give this and this state, that means if you have all those concepts at your fingertips, you will be on a very safe side. Again, we look at laws and principles. This is another target in examination. Laws and principles. There are quite a number of laws in physics. Dear friends, you are aware of that, as well as principles. So it is your task or your concern to know all those principles. And all these laws are named after some people. For example, you can talk of Newton's laws of motion, the law of flotation. There are many. My concern is one, how do you state a law? Yeah, some learners normally say it states, but it's better to mention the name and say, for example, Newton's first law of motion states that, and then you do what? And then you proceed. You could say, if you go to the principles, we have very many, like the principle of moments, Archimedes' principle. Now for the principle of moments, one could say that the principle of moments states that when a body is in equilibrium, the sum of the anti-clockwise moments about any point is equal to the sum of the clockwise moments about the same point. So don't just say it states, oh, this is. No. Begin by mentioning that the principle of moment states that. Then you do what? Then you give your answer in that format. Look what an example of, say, Archimedes' principle. one could say that Archimedes' principle states that when a body is wholly or partially immersed in a fluid, it experiences an upthrust equal to the weight of the fluid displaced. So the word fluid is very important. Some learners mention water. Well, no, that's not correct. We normally use the word what? Fluid. So when a body is wholly or partially immersed in a fluid, it experiences an upthrust equal to the weight of the fluid displaced. So laws are very many. You can think of all those laws, but just try to remember how you give or how you state the various what? The various laws and principles. Another target which you look at in these exams we test the theories. As far as O-level is concerned, actually we don't have very many theories to talk about here. The most notable one which we normally talk of, we talk of the kinetic theory. We talk about the kinetic theory of matter, and maybe we can as well mention the domain theory of magnetism. So I think that's what we look at O-level. So the first is very, very common, and in most cases it will be required just to state what? To state the kinetic theory of matter. And here we have to give the statement. It is very simple to remember. For the domain, at times it appears in paper too, but in case it surfaces, again you have to give it what? To give it due attention. But again, when you are starting, always mention that the kinetic theory of matter states that. Then you do what? Then you add maybe other collaborative words. So don't just leave it hanging. Always mention that, and then you do what? And then you proceed. So you don't have to dwell much on this, but just remember some theories. Basically, here we have two. I've already put it clear. That is the kinetic theory and maybe the domain theory of magnetism. Again, exams target or focus on. Exams will center on applications. They will center on applications. I have put it clear that one will look at terminologies of concepts, the various terms. We look at laws and principles. We look at theories. All this must be committed to your memories. Then we look at what? Applications. We look at how we apply physics to real life situation. That's very important. I look at caseless surface tension. If you look at simple machines, wherever you go, we make use of what? The machines. If you look at maybe at the case of what? The cranes, when we are raising heavy loads, maybe to higher levels, we normally use what? We normally employ the knowledge of what? Actually, the science of what? Pulleys. So when you are reading, try to look at the practical applications or the real life what? The real life applications. That's very, very important. And finally, under the targets, it is problem solving. Problem solving. Yeah, in most of the questions for physics, there is no way I will dodge problems. When I say problems, well, these are not real problems, but these are just questions or moments, of course, which require some mathematical computation or some knowledge of what? Mathematics. But as I already put it, once you have the basic tips, the moment you summarize everything as it has been given, you'll be able to come up with the required solution. Sometimes you'll be given content which is too much, which may not actually be required at times, but try your best and summarize what has been given. Look at what is required and maybe what you don't want. Definitely at the end of it all, you'll be able to come up with the right solution. So problem solving is another important aspect which you should remember. Try to commit to your memories. So that was the second item under questioning approach, and that has been the examination targets. Now the third item is the keywords. So when we talk of the keywords, here we are looking at the hints, the suggestive words. You can call them catchwords. Those which guide us. And I'm going to give a number of examples. So just know keywords, these are simply hints, suggestions, or the catchwords, which you should expect in paper 1. And once you have all them, maybe if you have them at your fingertips, you'll be in a position to come up with the required solutions. So what are some of these keywords? One, define. Now when they say define, what is required of you? You have to give a formal statement. You have to give a formal statement of the meaning of a concept or a term. Here you give a formal statement you give a formal statement of the meaning of a term. The examples are many. For example, define momentum. Define momentum. Now, how do you define momentum? I'm giving just an example. The question may be define the term momentum. Define the term momentum. Now, what some candidates do, they just say, this is. Maybe if it is number 41, part A. I'm giving an example. Number 41, part A, this is paper 1. Somebody could say, this is. That is not proper. Don't say this is. Don't say it is. There are so many ways our learners begin that question. But when you are defining something, you have to be precise and concise. When I say precise, you have to be exact. And then concise, you must be very clear in your definition. And ensure that you include all the essential or the catchwords, the important terms must be included in your definition. So how do you define momentum? Don't say this is, just say momentum. Momentum is the product of mass of a body so that's how we start. So you can see the first word here, it is momentum. What are we doing? We are defining a momentum. So you begin that momentum is the product of the mass of a body and its what? And its velocity. That's how we begin. But once you say this is the product, and then you continue. However much you say very good words at the end of it all, it will somehow cost you. So remember, I will start. Momentum is the product of the mass of a body and its velocity. Define maybe energy. Don't say this again, you say energy is the ability or the capacity to perform what? To perform work. Define matter. Matter is anything which has mass and occupies what? Space. So that's how we handle what? That's how we handle definitions. Yeah, this is a term which you will never avoid. It will be surfacing almost everywhere in paper 1. It's very common. And some learners move out celebrating when they have not or maximized whatever was required. So please try to remember how we give what? How we give our definitions. But as I said in the start, these are very many. Try to remember very many. You have to read very hard because this paper is somehow wide. So you try to read, and then when you read, you definitely come up with whatever is required. So that's one of the key words, define. The second is state. This was an example. Defining momentum. So this is one of the most sensitive areas which you have to remember. So number 2, it is state. Now when we are stating, we give a brief answer. Don't attach some detailed information. Don't attach supporting arguments. We give something which is what? Actually something which is brief. It's a brief overview. So you don't have to go into details to explain. Some runners at times, they tell them to state and they end up doing what? They end up explaining. They end up defining and so on. I'll give an example here. I'll give a very simple example. State 2 examples of what? Forces. Maybe this is a simple example. State 2 examples of forces. So we are talking of 2. Actually, this is also important. Let me try to underline it. State 2 examples of what? Forces. So in that case, you don't have to go into details maybe to define the forces. Just come and maybe begin your answer. If you say number 45, part A, then you can use bullets. Maybe you can talk of centripetal force. Centripetal force. You can talk of gravitational force. And so on. But now, they have told us to give 2. What some of you do, when they say give 2, you give 7, they will be wasting your time. Just give 2 and look what the best examples. Give the best examples. Don't go to the moon, just give the real life what? Examples. Centripetal, we know it very well. When you talk of gravitational force, this is a very good example. So try to give only what? Only 2. Don't give as many as possible. So give only 2. And don't explain. Just do what? Just stop there. What some runners do, they mention centripetal. Then they go on to define centripetal what? Centripetal force. That's not proper. I said give a brief overview. Just give the answer and then you do what? And then you carry on. You can think of some other examples. For example, they can ask you to give maybe some 2 uses of what? Pulleys. Some 2 uses of machines. If maybe we were to make it general, they can talk of machine, they can talk of pulleys, whatever the case. Again, let me try maybe to emphasize this. If we are required to give or to state this is another example. You can say state 2 applications of pulleys So what are we expecting? Look what two best answers where we make of what? Where we make use of police in real life. And I said in the start, our teaching, when you are reading, you should look what the real life what? Application is. So where do we make use of pulleys? One could look what? Pulleys may be being used in cranes, but to do what? To lift heavy loads. So you could say that pulleys are used in cranes to lift heavy loads. So in this case, what I want to bring to your attention is one simple thing. If you say pulleys are used in cranes and stop there, it will be penalized. You have to tell us what do they do in what? In cranes. So we are saying that pulleys are used in cranes to lift heavy what? Lift heavy loads. So when you stop here, your point will be redundant, and in that case you'll end up losing some scores. So you have to tell us what does it do in pulleys. You can give maybe another argument here. You can talk of the application at maybe the flagger poles. Yeah, you can say flagger poles. Flagger poles use pulleys. Now when you stop here, again it is very dangerous. They use pulleys to do what? So flagger poles use pulleys in order to hoist, that's to raise, in order to hoist the flag up, that's raising it up, or to bring it down. Yeah, it may look a little bit lengthy, but that's how meaning will come out. So flagger poles make use of pulleys to do what? In order to hoist the flag up or to bring it where? Down. So that's how we state, or that's how we make use of what? State. So don't be detailed, try to look what? Stick to the essentials, and when you do that, you'll be on a very safe side. Number three, after state, we can talk of outline. Again, outline is not different from state. It's almost the same thing. State, give. So outline. Again, when you're outlining something, you have to give a brief overview of the topic under study. You give a brief overview of the area of concern. So again, don't attach what? Supporting arguments. Don't be over detailed. Just stick to the essentials. For example, you can say outline 2 examples of vector quantities. Then you go on to say, to give maybe velocity. You can talk of momentum. Now, danger is one that someone, when they say give 2, they give 4. They begin with maybe the wrong option is, and at the end they give what the right option is. So the moment you give like 4, when the first 2 are not correct, you'll be in danger. So try to give the most correct alternatives at the start, so that maybe at the end when you misfire, you don't get challenges. So when you forget that, you'll be in danger. If you give very many, we mark the first what, the first 2, the first 3, depending on what was required. Another term which is very important, which you should commit to your memories, that's number 4. Actually, there are some 2 sister terms here which are sometimes confusing. We have distinguish, and then let me handle even this number 5 at the same time. Differentiate. Now, when we say distinguish, what are we looking at? Well, somebody may say we're looking at differences, but first we want you to perceive and recognize, or actually you can perceive or recognize and understand the way our 2 concepts are different. Now, at our level, what do we have to know? Distinguish, what do we make use of? Okay. Distinguish, make use of what? Make use of, the definition is. Differentiate, yeah, you can make use of what? The differences. So, that's that. Number 6, we are running out of time, but let me try to summarize. So, number 6, you can talk of compare. With compare, you point out the differences and similarities. Maybe if you are comparing mass and weight, look what the similarities as well as what the differences. Don't just give lists, maybe these are differences. Try to maybe to explain, bring it out very well so that somebody maybe reading can do what? Marking, somebody can understand. So number 6 is compare. Number 7 it is calculate. Calculate or find. In that case, what we need is we want a workout, maybe to a numerical problem. So when you, when they say calculate, find, there we need a solution to a numerical problem. And lastly, there is sketch. Actually, last but not least, there is sketch. You need a sketch drawing to guide you. And the number 9 actually, it is explain. So in explanation is, again, these are usually 2 marks. What we normally do, we look for a reason for something occurring. But again, don't go into detail, don't be detailed, just try to give what? Just try to give a reason, and then you do what? And then you stop at some point. So friends, dear candidates, basically that's what you have to remember. Try to look at what we have discussed, and I believe when you do it very well, you'll be on a very safe side. I'm certain that what I have mentioned here is very important. Try to put it in practice, and when you do that, you will never regret. So it has been a pleasure taking you through this session. I'm stopping here because of time. Till next time, Ssaabasajja Kabaka awangaale.